Welcome everyone! Today we will learn how to implement Elasticsearch filters in a .NET Web API. As a prerequisite, we need to have a running Elasticsearch instance. You can check out my video. I'll put the link in the description below. And a Kibana running instance to add sample data. Okay, so go to Visual Studio. The second prerequisite for this demo is to use a simple clean architecture structure. You can also check out my video about what is clean architecture. I'll provide the links in the description below. Okay, so the first step is to add the credentials of our Elasticsearch instance. So go to the add settings.json, define a section called Elastic, which will contain the user. By default is Elastic, and the secret, which will be the secret of our Elasticsearch instance. So let me copy the password. The second step is to add the Nest NuGet package in the persistence layer. So go to manage NuGet packages and search for Nest. Install the latest stable version. The third step is to register the Elasticsearch client. To do that, we will add a new class called persistence installers in the persistence layer. Let's create as a static class with an extension method called add persistence services based on the iService collection. Okay, services. This interface is to register the services from the API, and the second interface will declare as a parameter the configuration, configuration to access the add settings.json values. So install the required NuGet package. Let me collapse this one. Access the section from the last add settings.json to get the user and the secret. So add a variable called section, called configuration that gets section by passing the name, which is Elastic. And then add a property called connection settings to configure all the necessary aspects for the new ElasticClient. So add a new connection settings object by defining the URI, which is HTTPS localhost and the default port, and add several options. The first one is the basic authentication by passing the username and the password based on the add settings.json. Okay, the key for the user, pass the name, and the second value, which is for the secret. Okay, add a server certificate validation callback just to trust the local certificate because we're using HTTPS. So called certificate validations class from Elasticsearch.net to allow all. And finally, we'll select or define a default index with the name product. Inject the ElasticClient as a singleton by creating a new ElasticClient and passing the connection settings. Okay, the next step is to define the generic repository to add the filter method. So in the persistence layer, let's replace the name of this database service as generic repo of type T, and where T is a reference type, and define the method that we will use in the generic repo. So this will be an asynchronous method that will return a list of type T. Okay, this is a generic method. Okay, define the name, filter, and we'll pass a specific argument. Inject via constructor the ElasticClient, define a field, and then declare a variable called response and call ElasticClient that search async to apply all the filters. This search async go to definition will receive a selector that will contain the query. Okay, let me copy this function, and the idea is to pass a lambda function with the query from the argument method. So the query is another type, so go to the definition of this function. This will be the parameter for a filter method type T. This is type T, and pass the query. These all definitions about Elasticsearch types based on functions to apply the filter. Okay, pass the selector, and the idea is to return the response that documents and convert to list. We define the implementation of the generic filter. Let's declare the the contract in the application layer. This will be a generic repo with the method. This is of type T, where T is class, and used Elasticsearch, the nest package. The interface and the class implementation are done. So the next step is to register this generic repo in the persistence installer. So add a scope based on the service type, which is the iGeneric repo or the contract, and the implementation is the class that implements the filter method. That's it. Go to the program.cs file in the API and call the method add persistence services and pass the configuration interface. That's it. The next step is to go to the domain layer and add the product class, which will represent the document modeled in Elasticsearch. Let's replace the name of entities as indexes because the product will be an index, not an entity. Replace the namespace and define the fields. We have name, we have brand, we have an array of colors, and finally a property for the price. The next step is to define the product filter DTO, which is the input body in the web API to apply all the filters. So go to the application, add a new folder called DTOs, and add a class called product filter DTO, which will contain similar fields from the product class. We will filter by name, we will filter by brands, not just by one, but by multiple brands, by multiple colors, and we will pass a price range. Okay, the next step is to implement the filter for products in the controller. So go to the controllers, replace the name of the user controller as product controller. This would be HTTP post, which receives, replace the name, which receives a product filter DTO as an input body. This will be nullable because if the DTO is null, we will match all the documents from the index. Let's define the filter. This will be an asynchronous method. So add the filter, go to the generic repo to copy the function or the query itself, the object, and define the query. So this will be a lambda function. We'll use a ternary operator to check if the DTO is null. If it's null, we will match all the documents. Okay. Otherwise, we will apply all the filters. The first filter is filter by name with the match filter. This match filter returns the documents that match a provided text. So apply this filter by calling the match filter by passing the field, which is, let's replace this T with the specified type, which is product. So the field will be the name, okay, and we will query based on the DTO.name. We will create a concatenate filters or an aggregate filter based on the AND operator. The second filter would be temps. This returns the documents that match one or more exact temps in the document. So in this case, we will apply this temps filter to the brands and to the colors. Okay, so define the field. The first one will be the brand based on the DTO.brands. And similarly, for the colors, it has a slight change in terms that the product contains multiple colors and the brand contains just one single brand. So this is the unique difference, but we will apply the same terms filter. And the final filter is for the price range. So add a new filter called range, but before using the range filter, we will validate if the DTO.price range contains any element. If it doesn't contain any element, we will just apply ternary operator, we will just return null. With null, we'll ignore the filter. Otherwise, we will apply the filter, okay? So add parentheses, and the first filter will be the range to the specified field. The field is the price, and we will validate with the less than or equals function be less than or equals that the price range, the maximum value that is in the position 1, and the second range filter is the same field but greater than or equals that price range or the minimum value that is in the initial position of the array. Let's add it, and we have the price range. Let's close the parentheses, and that's it. We define the particular product filter based on multiple Elasticsearch filter, the match, temps, and range for the price range. Okay, that's it. Then we will return the response from the generic repo. So we need to inject the generic repo via constructor injection by calling the iGeneric repo interface of type product, declare a field, and return repo.filter by passing the query. This is an asynchronous method, so add the await keyword. That's it. We've implemented the product filter. Let's go to the Kibana DevTools console to add sample data. So here in this console, I will use this bulk operator to add 2 documents to the product index. Okay, so execute the command. They are created. Let's validate it by getting the results from the product index. We have 2 products. So far, so good. Now it's time to test the API. Run the project. We have an error. Okay, let's remove this old method because it's not necessary. Let's execute it again. Test the name filter by removing the arrays, the price, colors, and brands arrays, passing the name, in this case shoe, to apply the match filter. As you can see, it returns the 2 documents, the 2 only documents that we have in the product index because it contains the shoe what. Let's replay it by SSS. It will return just 1 document. So far, so good. The second filter is the brands, which use the temps filter. We'll pass the first brand. So we have 1 document, but I want to get 2 documents. We pass in the second brand. We have the 2 documents. Test the colors filter at black. We have just 1 product, but if we add white, we have the 2 documents because both contain white color. And finally, test the price range at 25 to 30. Both products are into the range. Let's change it to 26, and we have just 1 document. And we can remove all the request body and check if we have all the documents using the match all filter operator. We have all the documents from the product index. So in this demo, we learned how to apply Elasticsearch filters in a .NET Web API.